Hello everyone. Welcome back to this channel. This is the question about network analysis and which is asked in GATE 2025 this year only. And this question was asked in 2 marks. So what is the question? Let me understand and what is asked to find in this question. So in these questions we have given a circuit diagram which consists of several resistors and this pattern is following till infinite times in both the side. Okay, and question is about to find the value of the voltage at this node X, which is Vx. So four options are given. Options are 20 divided by 3, 32 by 3, 22 by 3, and 2 by 3. So let me try to solve. How can we find the voltage at node X, which is Vx in this question? So first of all, I assume a potential at this node as voltage Vy as I consider this is node Y. So, to solve this, when we know the potential at one terminal of the resistor and we know the branch current of the resistor, we can easily find the voltage at another node, which can be found by using Ohm's law. And here, Vy will become nothing but 9 minus 1 into 3, which is 6 volt. So here we know the voltage, which is 6 volt right now, and to find the voltage at node X, which is Vx, we first of all we have to find the current in this branch. If we can find the current in this branch, Vx can be easily calculated as Vx as 8 minus 2i. So our aim is to find the current in this branch across the 2 ohm resistor or 1 ohm resistor. We can easily find the voltage which is asked in this question. So how can we find the current? It's very easy because I consider this is the voltage 8 volt at this node, and here voltage at this node is 6 volt, and these two resistors are in the series. So current is can be easily find by 8 minus 6 divided by sum of these two resistors, which is 3. So current is 2 divided by 3 ampere as resistors are given in ohms only. So Vx will become 8 minus 2 multiplied by 2 by 3, which is equal to which is equal to 24 minus 4 divided by 3. So Vx is nothing but 20 by 3. It's good question and very easy question if you understand this circuit very carefully. So what does it mean? It means that there is no significance of this entire circuit. There is no significance of this entire circuit. This is what means here in this question. Thank you for watching this video.